So in this note sheet, we are going to look at dilations and how can we dilate a polygon or a figure on the coordinate plane. So far we've done translations and reflections, and so dilations is going to be the third transformation that we look at this unit. So for starters, what is a dilation? A dilation is a transformation that makes a shape bigger or smaller. Okay, so that's where they are two different sizes. We use a scale factor to know how much to shrink or stretch the shape. So the scale factor is going to tell us whether we're making it bigger and by how much, or whether we're making it smaller and by how much. There, that's your focus. A scale factor bigger than 1 is going to make the image bigger. You know, that makes sense, right? So examples of those scale factors could be 2, 3, 4, so on. Anything that's bigger than 1. A scale factor smaller than 1 will make the image smaller. And so examples of that would be like 1/2, 1/3, 1/4, etc. Okay, anything that's smaller than 1. So if the scale factor is bigger than 1, it's going to get bigger. If the scale factor is smaller than 1, the shape is going to get smaller. And so next what we're going to do is we're going to actually do 3 dilations, and I'm going to show you how you dilate on the coordinate plane, and in my opinion it's pretty easy. So on the bottom here we get to our first example. So it says, how do we dilate on the coordinate plane? And so in order to dilate, we multiply both, and that's really important, both the x and y values of the original coordinate points by the scale factor. So let's look at this first example. And I'm going to focus for right now, I'm just going to focus on the numbers, so you won't see the picture. So we're dilating this with a scale factor of 3. So what that means is, and I'll do p down here for an example, is we are going to be multiplying both the x and the y value by 3. If you remember the distributive property, we can kind of think of it that way. We're going to take that coordinate point and multiply both of these by 3. So that's going to turn into 3 times 1 is 3. 3 times 3 is 9. So we started with 1, 3, and when we use a scale factor of 3, that's going to turn into 3, 9. And so I'll show you one more with point Q. So again, our scale factor is 3, so we're going to be multiplying both the x value and the y value of that coordinate point by 3. So 3 times 4 is 12. 3 times 3 is 9. So Q is going to be 12, 9. So let's try R, and let's see if you can do it maybe without all of this writing. If R starts at 4, 1, and we're using a scale factor of 3, what is R prime going to end up being? Well, 4 times 3 is 12. 1 times 3 is 3. And so what about S? One times 3 is 3. 1 times 3 is 3. And so now we have our ordered pairs for our image. So let's draw this and see if it looks right. So P prime is at 3, 9. So 3, 9. Q prime is at 12, 9. So we're just going to go over here. I'm just going to add 11 and 12 down here on the bottom for myself. 12, 9. It's right here. R is at 12, 3. So 12, 3. And S is at 3, 3. So if we look at the shape that we end up with, it's just a bigger rectangle. And that's what dilation should be. We started with a rectangle, we're going to end with a rectangle. It's just going to be 3 times bigger. And you can see that this one's pretty small, this one's a lot bigger. So again, when you are doing a dilation, all you end up doing is just multiplying the x and y values of every point by that scale factor. A lot of times students make mistakes and then they'll only multiply the x value or they'll only multiply the y value or whatever, but you got to multiply both of them. So in this case, it's stretched. It got bigger. On the back, let's look at some examples where it gets smaller. So again, here's our triangle, ABC. I'm just going to zoom in right here on just the numbers for now before we go and plot the image. So with this one, we're dilating with a scale factor of 1/2. We start with 2, 8, 2, 2, 8, 2. And so again, I'll show you right here. Now we're doing the same thing, but our scale factor is 1/2. We're multiplying both the x and the y values by that 1/2. Now, if you want to use 0.5 instead of 1/2, that's okay, that's fine. They equal the same thing. So 1/2 times 2, sorry, down here, is 1. 1/2 times 8 is 4. And so A ends up being 1, 4. Can you tell me what B would be? Two times 1/2, or 1/2 times 2, is 1. 1/2 times 2 is 1. If you didn't get B on your own, I'll show you one last time with C. If you did get B on your own, see if you can beat me by figuring it out first. So point C starts at 8, 2, and we have a scale factor of 1/2. So what we're going to do is multiply that 1/2 times 8, and 1/2 times 8 is 4. 1/2 times 2 is 1. And so now we know that our image point for C is going to be 4, 1. Some of you might be noticing that multiplying by 1/2, you're like, well, wait a second, that's the same thing as dividing by 2. And you're absolutely correct. Okay, so if you see a scale factor of 1/2 and you want to treat it as division instead of multiplication, you're entirely welcome to do that. I just don't want you to get confused when the scale factor changes back to being a whole number instead of a fraction. So now that we have our image points, let's plot these and see what our picture looks like before we're done. So 1, 4, it's going to be our A prime. B is going to be 1, 1. And C is going to be 4, 1. And so when we connect those back together, again, the pictures, it's the same shape. Okay, here we started with a triangle, here we have a triangle. It's just that we have now made it smaller, you know, more miniature, kind of like a fun-sized triangle. And so that's an example of how, since our scale factor was smaller than 1, and our scale factor was a fraction, we ended up with a shape that's smaller than what we started with. So with this third example, what I really want to encourage you to do is to use the same method that we just did with the 1/2, but now our scale factor is 1/3. So it's a little bit different in the sense that we can't just turn 1/3 into a decimal because it's 0.333333333. So you're going to have to get yourself in the habit of using that calculator and doing 1 divided by 3 times blank, all kind of pretty quick. But I want you to do right now, I want you to pause this video. I want you to try this one by yourself. And when you've finished, then you can hit play and see if you got the answers right. So I'll give you 6 seconds to pause this video, try this one for yourself before I show you the answers. Okay, so when you attempted to do this problem, again, I'll show you with 1 point. Our scale factor is now 1/3. And I'm going to be multiplying that by my original coordinates, which is 6, 9, not the wrapper. So 1 divided by 3, or 1/3 times 6. 1 divided by 3 times 6 is 2. 1 divided by 3 times 9 is 3. And so you should have ended up with 2, 3 for that last one. For B, again, the idea is the same. I'm multiplying both of those coordinates, or both those coordinate values, by 1/3. 1/3 times 3 is 1. 1/3 times 3 is 1. And again, maybe some of you realized, oh wait, it's the same as just dividing by 3. You're entirely correct. For C, you should have gotten 9 times 1/3, 3, and 1. So those are the points that you should have ended up with. When we go to draw that image, A is going to be at 2, 3. B is at 1, 1. And C is at 3, 1. Connect those together. And there you have it. Again, looks very similar. It's still a triangle. It's just a miniature or small version of that triangle. If you have any questions, again, please ask me. Please come after school, do what you need to do. If you're in my first period class and you're watching this video because I'm not there, be nice to the sub, be good, complete the classwork that I'm asking you to complete, and enjoy the rest of your day.